On page 74 in your packet, you have a little math note about describing association. When we look at an association, in this particular case, we're going to look at an association between two numerical variables. So, for example, we might have study time versus the grade in your class. If I went around and took a look at all my data in my grade book, I might notice that those who study less score less and so forth. So we end up with this kind of relationship that appears to look kind of like a line. And in fact, we call this a linear relationship. Okay? At the beginning of the year, we also looked at some data where somebody was sick and they were coughing on people and they were getting more and more people sick. And the graph kind of looked like this, right? It started to grow, kind of shoot up like that. This one's called an exponential relationship. So these two different types of, so this was time and number sick. So both of these relationships describe the form of the association between study time and grade, between time and the amount of people sick. Right. The other way that we could describe an association between two variables is we could look at the direction. Direction, in this case, is just like what you've already been doing. It has to do with slope. So in this case, this is positive. This has a positive growth. So let's take a look. The other than positive, right, we looked at slope going down. So that would be a negative. So let's take a look at an example of a negative direction. So if we wanted to look at amount of time over money that I have in my checking account. So I might have over the, every month I get paid, so I might have this much money, and then over time I see this relationship. If I do it from month to month, I might have this. Sometimes I spend more, sometimes I spend less. And we end up with the scatter plot of various months. And still, this is a linear relationship, but it's going down. Because through the time of the month, my money in the bank goes down. So we call that a negative relationship. Finally, there's the strength of the relationship. The strength of the relationship depends on how tight these data points fit around whatever form I have. So for example, I might have something that is pretty tight, linear, positive, right, that looks like that, versus something that's a little bit more scattered. We can still see the linear relationship or the linear association, but it's not as tight around this line that I can imagine seeing. So this line of best fit that I might see that you've seen in 8th grade. All right, so we call this a strong association, and we call this one a weak association. And on the total other end, if it's just scattered like this, if I want to compare the number of people to the grade they get on a test, that it doesn't make sense to compare the two. I can create a scatter plot, but there's no association. So when we see this scattering, there'd be what we say no association. So this would be a weak and strong association. There's also the case when you have something that sits way outside the normal pattern of data, and the packet also talks about this being an outlier. So anything that sits outside of the normal pattern of data would be considered an outlier.